Well, good morning, everyone from sunny Southern California. We have folks participating today on this webinar from all around the world, and it's really nice to be with all of you during this strange time in our history. I hope you all have masks and you're wearing them in public, and hopefully we can bring this COVID pandemic to an end. Today, our focus is going to be on how to turn two-dimensional data into three-dimensional data for the PSAP. And our speakers are going to be John Brasowski, who's the Vice President of Innovations at Geocom. John is a longtime friend of ours and of ESRI. They are a strategic partner to us, and we're so grateful for the work that they do, and John for participating with us today. Thanks a lot for being here. And Phil Milkey will also be speaking. Phil is our 3D Web Experience Product Manager. Before he came to ESRI, he was with the city of Redlands, California, and served in 911 and as the department's IT director. We have a poll question that we would like to put in front of you, but could you take a moment and answer this poll? Does your jurisdiction currently have 3D data in preparation for next-gen 911 requirements? So we have the results in, and 77% of you do not have a 3D data strategy in place. So this is really exciting. We'll be able to hopefully help each of you get some ideas on some new things. For the 16% who are working on it, hopefully this will support your efforts and give you some additional ideas. And together we might be able to solve this problem, because it truly is a global problem. Let me now introduce John Brasowski.
Thanks, Mike. So first of all, I thought I'd start out with a question. Why do we need 3D for 911 at all? So I thought it'd be useful to start out by looking at some trends around how people actually communicate with 911 and from where, and what kinds of problems this introduces. So today, approximately 80% of all 911 calls originate from mobile phones. So in some cases, some jurisdictions, it's even over 80%. Also, an interesting statistic that you may not have heard, the average US citizen, according to a government study, spends 80% of their life indoors. I thought that was an amazing statistic when I first heard it. That was from that study was done a few years ago. So actually these days it may be even a little bit higher than 80% if you think about it. So it's just interesting because lots of us are getting rid of our old wireline, landline telephone services and just relying on our mobile phones for our primary method for communications. And the problem with that is that historically, wireless 911 caller location, so the ability for the 911 system to locate calls from mobile phones, it hasn't worked very well indoors, inside of buildings. So, and why is that a problem? Well, as an example, earlier this year, a Rensselaer Polytechnic Institute grad student in Troy, New York, you may have heard the story. The student had made a garbled 911 call from a cell phone, but couldn't communicate his exact location verbally before hanging up. Well, police and firefighters searched the general area for about 45 minutes, but they were unable to locate that caller. Several hours later, the student's roommate came home and found him dead in his room. He had died from severe influenza symptoms, tragically. So to be clear, while the nation's 911 system really has been a success for many years, including the life-saving ability to locate 911 calls from mobile phones that was implemented in the early 2000s, one place that location tracking technology for mobile phones during 911 calls doesn't work as well is inside of buildings. And that's because indoors is commonly a GPS-denied environment. So, you know, radio signal from GPS beacons on Navstar satellites in space, that radio signal can be blocked by rooftops and building materials. So it's hard for the GPS chip in your cell phone to get a good fix inside of a building. Additionally, the other types of location technology that 911 uses, like cellular radio signal location technology, those types of locations are often coarse-grained, which means they may be accurate to within 100 meters or 300 meters, which is a fantastic technology for locating callers. But if you think about it, if you're inside of a building, 100 meters or 300 meters, that could put you inside of the building or outside of the building in the parking lot or across the street in a different building. So in the indoor scenario, that type of location can be quite challenging. So thankfully, the industry and the 911 industry is well aware of this. And in particular, the FCC has created new rules that are requiring wireless carriers to implement technology that can identify indoor positions for wireless 911 calls, including indoors. And for the first time ever, these new standards and rules that are being put into place by the FCC also include a three-dimensional and elevation component. So in addition to what the FCC is doing with the rules for wireless carriers, there's additional technology that's emerging in the world today that's just getting better and better at pinpointing the location of mobile phones. And a primary example of that is what we call today device-based hybrid location or consumer location, where location services in a mobile phone's operating system, Android or iOS, can combine information from sensors in the phone like GPS, but also the Wi-Fi radio in the phone or BLE sensors, along with data that has been pocket sourced from 200 million other mobile phones that are out there roaming around the country. And all of that sort of combines to create a device-based hybrid location that in many cases can be pretty good inside of buildings. Additionally, GPS itself is going to get better. A couple of weeks ago, maybe you heard SpaceX launched a GPS-3 satellite. That's the next generation of GPS sats in the Navstar constellation that'll, among other things, enable better signal acquisition and positional technology. Also, we're beginning to see the emergence of metropolitan GPS beacon systems like the NextNav service, where the GPS radio beacons are mounted terrestrially on towers and rooftops of buildings instead of on space vehicles, and that enables better in-building performance because the GPS beacon signals have at place position terrestrial have better building penetrating capabilities, and also the geometry is a little bit different for calculating elevation computations. So in addition to that, we're also beginning to see really an explosion of indoor positioning systems. There's BLE beacon, Bluetooth Low Energy beacon based positioning systems, Wi-Fi based positioning systems, geomagnetic positioning systems. There's lighting based positioning systems that make use of smart LED lighting systems that are beginning to be installed in buildings. And that's just to name a few. So it's really an exciting time in mobile phone positioning, and when you combine that with 911, we really have a new opportunity to pinpoint 911 caller positions in 3 dimensions like we've never had before in the past. Really, all of those technologies combine into what I like to call the perfect coordinate. And that's represented by this blue dot on this slide. It's a blue dot that's perfectly positioned in space, latitude, longitude, and height above ellipsoid. But as you can see, without any supporting map information, it's just a blue dot on a blank whiteboard. It really isn't very useful. You can think a little bit more about what these raw positioning measurements are and what they mean. I mean, we can talk about what latitude and longitude are, and we can talk about what height above ellipsoid means and what the ellipsoid is. But at the end of the day, raw geodetic measurement is just a numerical measurement and isn't really all that helpful to human users without a corresponding map to put it into context and make it actionable. In fact, last year when the FCC did some additional rulemaking around the 3D, the elevation component requirement for wireless carriers for 911. One thing that they pointed out was that the rules are going to require the carriers to provide this sort of raw geodetic measurement, but 911 PSAPs and emergency call centers and emergency responders are going to need to implement systems and technology that can convert these raw geodetic measurements into actionable information that can be used to actually reduce emergency response times. So a numerical, highly accurate positional measurement is one thing, but making it actionable is another thing, and that's going to take some work. And so some examples of this, we certainly believe that the thing that makes raw geodetic measurements actionable are maps, including three-dimensional maps and indoor maps. What the pictures that you're looking at on the screen are from some R&D that Geocom did with College of Science and Engineering at a university in Minnesota, St. Cloud State University. We started looking at this about 4 years ago when the FCC started really coming out with these new rules. And our goal is really to see what it would take to build 3D maps and to track mobile phones inside 3D maps, and also to learn how 911 PSAPs and ECCs and emergency responders would interact with 3D map information in order to locate emergencies quicker. Not surprisingly, in the real world operational test that we did, having a 3D map pinpointing the caller on the right floor of a right building inside of a room decreased the time that it took emergency responders to find the caller. So some of the technology that Geocom used to build out these systems and these tests were ESRI technologies. So we used tools like ArcGIS Desktop and ArcGIS Pro to author 3D maps. We use the ArcGIS Pro SDK to create a 3D dispatch mapping solution that we pretty quickly after that migrated over into the ESRI 4.x JavaScript API, which now has pretty fantastic 3D visualization capabilities. Now we use tools like ESRI Drone to map to quickly capture 3D surfaces outdoors. And then we used ArcGIS Enterprise and Portal and Online to make those 3D map views, well, to publish them and distribute them across the internet. We used tools like GeoEvent Server for ArcGIS to track calls and assets moving around inside of those three-dimensional views. So actually, this the screen that you see on the screenshot that you see on the left side of the screen here, that's a high school. This was just a great example because we were able to take a consumer grade drone like you just buy at Best Buy or a hobby shop, really hobbyist grade drone. We were able to fly over a high school in this case, and then using drone to map, create a 3D map that could be published to ArcGIS Online really in no time. This whole process took just a couple of hours. And then the resulting map display, this is just a web map, 3D web scene in the scene viewer in ArcGIS Online with no special custom programming or anything like that. No custom software development, just tools, ESRI tools out of the box. You can see how now we can measure in 3 dimensions. We could see what how tall of a ladder you'd need to bring to get through a window or get to the second floor and so on. Just really fantastic tools. Some of those sort of earlier prototypical exercises really led to a full-scale operational 3D and indoor mapping deployment that we did for Super Bowl 52. In this case, we built a very highly detailed 3D and indoor map of US Bank Stadium and a 3D map of Minneapolis. And then inside that 3D and indoor map of US Bank Stadium, we connected it to a variety of sensor feeds. So several thousand cameras, hundreds inside the stadium and even more outside of the stadium. We connected it up to multiple incident management systems, computer-aided dispatch systems, access control systems. We were tracking the location of emergency responders indoors using BLE beacon proximity. There were a couple of thousand BLE beacons deployed throughout the stadium. So just really a great example of 3D and indoor mapping connected up to real-time feeds from IoT sensors, all enabled by ESRI mapping technology. So, and that was used as a common operating picture by over 80 different public safety agencies during that particular event. And so, what do we learn from that? Well, we learned that absolutely 3D and indoor maps are very useful tactically for emergency response situations, especially for complex indoor geographies. But we also learned that scalability is going to be a challenge for 911. And so as we think about how to scale this technology, we're really looking at economic feasibility, but also sustainability. So building these types of maps, it's not a one-time a job. It's an ongoing process. You have to keep maps up to date over time, and buildings change. New buildings are constructed, old buildings are torn down or remodeled or enhanced and modified. So it is really an ongoing effort. And it also, as we look at scalability, we can kind of think about simpler ways to do 3D mapping. So on the one end of the spectrum is like we did for US Bank Stadium, where we did a really highly accurate 3D model. We had 3D BIM files, CAD drawings from the architects that designed the stadium, and it really resulted in a photorealistic 3D representation, a digital twin of the stadium. But on the other hand, like we see on the screen here, simpler approaches are just like taking two-dimensional building footprint polygons and extruding them into 3 dimensions. And so in this case, we took some two-dimensional building footprints actually created by Microsoft. And in this case, it's actually hosted in ArcGIS Online as vector tiles. ESRI created vector tiles of that national building footprint database. You can extrude them into 3 dimensions, and that gives you these sort of volumetric representations of buildings. And you can see that if you were to position a 911 call within one of these 3-dimensional building shells, that gives you tactical information. You can tell if a caller is on the ground level, or if there may be up towards the 5th level, or if it's a 20-story building. It definitely can give you actionable information to help you narrow down where a caller is. So at this point, I'd like to pass it over to Phil, who's going to take a deeper dive into the ESRI technologies that make these kinds of 911 tactical mapping applications possible, and really also how to take it to the next level in terms of making 3D position measurements actionable for reducing response times. But real quick, before I pass it over, I just wanted to quickly highlight an announcement that Jack Dangerman made during the UC plenary session last week about a collaboration between ESRI, Geocom, and a company called RapidSOS to bring advanced mapping technologies to 911 PSAPs across the country, including indoor mapping. You can read about it in the ESRI newsroom, and there's also an ESRI landing page on the topic where you can sign up for updates, so you can sort of stay in the know on this topic. But this is really all about taking those device-based hybrid locations that RapidSOS has found a way to deliver for 911 calls to 911 PSAPs, and to integrate it with advanced ESRI mapping that it can include 3D maps and indoor maps as well. And so with that, I'm going to pass it over to Philip.
All right, thank you, John. So my role at ESRI, I'm the product manager for Scene Viewer and 3D experiences on the web. And I've been really happy to see the advancements in technology that we've made just over the last couple of years. And it really puts 3D GIS as a fully supported aspect of the ArcGIS platform. I know there's a lot of our attendees that have been utilizing GIS as either a part of their dispatch systems or crime analysis programs. And the message here that I'd like to relay first is 3D GIS is ultimately GIS. It's something that is fully supported. That's you can utilize ArcGIS Online and Enterprise for a variety of different solutions and experiences to be able to maintain that data just like you would your street data or addressing systems, geocoding systems. And it is something that really leads towards some beautiful experiences towards the end. As Mike had mentioned earlier, I previously worked in the Redlands Police Department, and one of my roles was implementing a dispatch system. And at the time, 3D GIS wasn't accessible over the web, but there were a lot of different use cases and scenarios that I'll show you that I think really could be better supported and give both dispatchers and first responders a better picture as they're approaching response. And it's about preparedness, and in this case, understanding what are the scenarios that are necessary in order to create the data that you can produce your own 3D viewer and be prepared for next gen 911 requirements. But before I do that, one of the things I'd like to show you is a bit of the art of the possible here. The reasons why ultimately having 3D as a component for understanding the location of a call really comes into play here. So what I'd like to show you first is this is X, Y, and Z data along with uncertainty for calls as they're coming into San Diego. You know, this is a simulation that we have here, but there's components here that I think are worth understanding, especially as we're approaching location uncertainty. And this is how we've symbolized a lot of this data so that we can see location uncertainty when it comes to horizontal and vertical. If it's small, you have a smaller area of certainty. And if it's a bit larger, depending on the GPS signal or any other kind of location, we can identify uncertainty and visualize it here with large horizontal or large vertical uncertainty. Knowing this information as it's coming in from a PSAP potentially gives us a better perspective in terms of being able to understand where those calls are actually coming from. So here's an example here. Seeing this call for chest pain and also understanding the overall the uncertainty. It says large horizontal uncertainty, but a smaller vertical uncertainty. And it helps to give you a perspective as far as where some of these calls are within building. In the background here, we have higher detailed buildings, but we don't have the full picture inside. And we'll also show some strategies for being able to get to that. But this helps to give that, that perspective on the value that 3D can play when it comes to both next gen 911 requirements. And this is something that falls on local jurisdictions for being able to maintain this authoritative data that provides context for these calls as they're coming in. So a lot of major cities, San Diego here being one, have already committed to a 3D program. You can see like Boston, New York, San Francisco. The central GIS departments for these cities have already developed and maintained a 3D program in which they're building out various buildings in various levels of detail and sharing those with first responders, public safety organizations, in order to understand really what's the best method that they can approach as they're understanding new capabilities and how to place some of these calls within 3D. So just to give you a sense as far as what this process looks like, this is a fairly technical diagram, but I'll make it pretty quick. Emergency caller will call in, and a PSAP will receive and compute both an X and Y location, but also a Z, and pass that through a relay client into, at this point, this is something that is maintained within a dispatch organization, so that here we're able to use GeoEvent server to enrich that call information with building information, building address and floor level, and then pass that enriched data onto Enterprise, which can hold all of the capabilities, the 3D maps, geocoding, routing, pre-planning solutions, AVL feed, potentially other city data that could be contextually relevant. And all, as this is using the JavaScript 4X API, dispatch systems can develop on top of this and bring 3D maps, like you're used to seeing 2D maps, into both the dispatcher view and MDTs, we're able to stream these scenes to mobile clients, and we've reduced the bandwidth that's necessary in order to be able to visualize 3D information. And we also have mechanisms in place so that 3D data can actually be cached and stored on mobile devices, so that really at this point within MDT, all of that 3D data can be cached there, and you're ultimately just passing on the location of those calls as they're happening. So this is the meat, I think, of the presentation, is that understanding those strategies for creating 3D building data for these kinds of workflows here. And what's important to recognize about this is level of detail. So the typical scenario here is LOD 0, where dispatchers and public safety organizations have found the value of building footprint data. And we ultimately just want to be able to understand how to take this into next level of mapping. So first, I'll show you about extruding that data and ways in which you're able to do that either through ArcGIS Pro or Scene Viewer. And then from there, we have some solutions, the 3D local base map solution, which will use LiDAR and the footprint data in order to create these appropriate roof forms. So your buildings look like buildings instead of, well, Jello cubes. And then from there, we can use and add texture in ArcGIS Pro to these buildings. And also, to take this on further to the next level, we can talk about some interior modeling so that we can both consume Revit as a data source for newer buildings where architects have designed those buildings in Revit, and take those architectural drawings and place them within a scene view so that we're able to have that full interior context of those buildings. So here's just a simple workflow in Scene Viewer. If you have the height information in your footprints, you can actually extrude them directly in Scene Viewer. That same data that's accessible in ArcGIS Online or Enterprise that your GIS folks have probably published and made available either as base maps or other data for geocoding. Given a height value, really all it takes is this process of using 3D extrusion styling in order to create this LOD1 view of that data. And this will do that on the fly. So it'll create those extrusions and allow you to be able to immediately start creating a 3D view of your city. In this case, we're looking at Vancouver Island here. Really interesting immediate capability that you already have accessible to you. And this is a very low investment in your time and energy to be able to create this kind of view. Again, this can be done in Scene Viewer, as I've shown, or it can also be extruded in ArcGIS Pro and shared as scene layers for faster performance. Now next, this is an example or a solution that we've created and have honed on for the past couple of years. And LiDAR is actually very prevalent in a lot of organizations. Cities will make the investment for understanding, watershed modeling, building more accurate ground models, understanding changes in vegetation over time and where there might be risks to mitigate. LiDAR has a great place in your tool set for being able to then create a 3D city like you're seeing here. And from that, this solution will actually work through a process that ultimately helps you to derive more value out of your LiDAR. It'll help to classify that LiDAR so it can tell the difference. You see all of these points of information that are here in this animated graphic. All of these points of information are LiDAR scan data, so that an airplane flying over the city will capture this data, and it's very accurate to frequently to centimeter accuracy, and it will give you that impression that looks, it's okay, it's useful as these individual points, but the ultimate value here is to then take these points and actually extract features from them. And that's ultimately what this solution will do, where you can build bridges, buildings, floors, and elevation. And there's also solutions for power lines to create vegetation and onto underground pipes, which don't quite apply here. So you can visualize information, you can improve your planning process, you can give context for your visualization, in this case, context of where those emergency calls are coming in. And it's also useful for flooding analysis too. The flood analysis is a 3D problem. And so what I'd like to do is to just show you this within a story map here. We've got one that's accessible that can go into a little bit more detail about how this ultimately works. And a part of this story map is understanding that we've got a lot of changes that are occurring in our built and natural environment. And there's this context of understanding what's happening and leveraging this LiDAR in order to create this 3D base map. So, in order to build these 3D cities, we actually start from the ground up. So part of the LiDAR classification process is that, understanding what each of these points are. And those points of LiDAR data that are showing here, you've got brown that's been classified as ground, green has been classified as vegetation, and red has been classified as buildings. This classification process is automated, and it's something that you can do with very little knowledge on the subject. And you can immediately get started by first classifying that data and creating a more accurate ground model, which really matters in this kind of workflow here. Once you've got that accurate ground model, then you can use those red LiDAR points that have been classified as buildings and your footprint data in order to extract realistic looking buildings that have an appropriate geometry that really match more about what's happening in with those buildings. This is taking that to the next level of detail. And this really enables you to then work through this extraction, develop those building footprints, and then from there, it enables you to, knowing the heights of those floors, can also give you a stratified sliced building where each of the floor levels are represented as accurately as you're aware of with that data. And then that can give you the information to understand which level of the building the call is coming from. As I mentioned before with geo-enrichment, the process through GeoEvent Server, just having the information of knowing they're in a certain section of a building can save lives and it can save time. And so, we can work through this extraction process to create these buildings, but then also break them up into these buildings, as well as trees, and we can visualize trees and bridges and other infrastructure, extract that data, and be able to really create some very realistic looking scenes that help to give the perspective of really understanding the context for where some of these emergency calls are coming from. This is just an example of the what that solution can create, so that each one of these levels are represented here, along with attribute information that can be passed on to that emergency call to help to give that kind of context when you especially need it. So this 3D base map solution is accessible online. It is free. It's a task-based workflow in ArcGIS Pro, which ultimately makes it much easier to follow step by step the processes that are necessary in order to extract information from LiDAR and create a beautiful 3D city. This can now be immediately implemented in online, where you'll find the application tab, at the top of ArcGIS Online, and currently this is immediately accessible in online, and it will be in enterprise, so that you're able to search for those solutions. You'll find 3D base map solutions and just click get it now. Again, this is free and it is pro-based, so that if you have a technician that's able to just operate ArcGIS Pro and step through a series of tasks, this is a great way to really extend and leverage LiDAR to create this kind of data. So the next level of detail here is more about actually getting inside the building. And this is a challenge. It can be a challenge, but it doesn't necessarily have to be, especially with newer buildings. So with our partnership with Autodesk, we are able to read Revit as a data source. Now, Revit is the program that architects use to architect and design a building. And it's ultimately that system of record that is used to pass to construction agencies to achieve buy-off for a plan. And it's a great source of information that is sometimes a bit large and unwieldy to just pass around and make decisions with. So now we have the ability to read Revit as a data source in ArcGIS Pro and publish what's called a building scene layer. And a building scene layer is the mechanism in Scene Viewer that we can then stream this rather large set of data very quickly in order to visualize and to see, use it as context, but also to have a system of record for where storage of some things are, things like Knox boxes or fire alarms, all of those things that are important contextually for first responders. Just an example of what this ultimately looks like and how it performs here in Scene Viewer. You know, I think the smoothness doesn't quite translate well over GoToMeeting, but what you're seeing here is you're seeing this building scene layer in which we have all of this information from that architectural design that's immediately visible and useful as a part of the overall base map. We can store and stream large volumes of information through Scene Viewer. And really the mechanism, I think that's important here, is to understand the performance. This is performant enough to be able to bring in your entire city of 3D buildings as was designed or as captured by the 3D local government base map solution. And then from here, this also gives that perspective on a greater volume of detail for those newer buildings, those buildings that are higher priority based off of security, and it helps to be able to give that kind of necessary context. Here I'm using the Building Explorer to cycle through the various floors, and we can also separate through disciplines and categories in order to, well, say we just wanted to get a greater detail on specific pieces of structure, if it's either the structural details or you know, specific disciplines and categories with this data. So there's a lot that's available here, that a lot of data, and ultimately this is a way that you can use to capture the value of that data and make it immediately accessible for decision making in the context of dispatching and first responders. So one of the other things to note here is ArcGIS Indoors. So Indoors is the solution that we have created ultimately for some other purposes, for campus environments that, you know, where there's wayfinding or operations, asset management, or space management. But we've seen this implemented on college campuses and corporate campuses, and it's another way in which we're able to develop a rich 3D interior base map that can be used in order to solve some pretty major problems, and also, I think, help to take it to the next potential for understanding interior positioning, which is also a potential component of Indoors. And using that interior positioning, we're able to visualize the locations of security staff here in this corporate environment. We also have some other details here. This is our tactical operations solution. Again, another free solution that's schema and symbology that's been predefined by working with a lot of first responders and understanding what kind of map elements are necessary. And by combining these, it gives us this overall perspective. Where are hazardous materials? Where's the locations of our entrances and exits, our evacuation plans? And having this kind of context at this close, at this level of detail on a local level, I think really helps organizations communicate with each other. They can securely share, a corporate environment can securely share this base map information with a central responding agency. And so that kind of brings out another strategy here for creating 3D maps, is that these can ultimately be shared securely with other organizations, just like data can be shared securely, crime data or AVL or the locations of calls. And all of this can come together to, I think, really flavor the potential for what a dispatch view of incidents and live AVL feeds can be, how that can be aided with the context of 3D mapping. So with that, I encourage you to ask some questions. And we actually have a question of our own here. Britt, would you like to take this?
Yeah, absolutely. So we have another poll question here, and it is as, will your agency work towards the creation of 3D data in support of next-gen 911 requirements? And there's three options. Yes, we're interested, but we're not sure how yet. B is, yes, we have staff and resources in place to do this. And lastly is, no, it's not a priority for us. So if you please submit your response, and then we'll kind of look at the results after a few moments here. All right, so the results are coming in. So I think this, this question really kind of ties a little bit to the initial poll question. And so I think the responses are somewhat consistent, but a little bit adjustment. I guess it's great that we're hearing that while a lot of people are yet to know how to pull this off or implement this at their agency or at their location, that they're interested, and that's really key, I think, here. So thank you again for everybody responding on this poll question and the previous poll question. So I wanted to go ahead and address a couple additional questions, and I will add that if there are any additional questions that people have during the remainder of this webinar, please submit them in the chat, question chat area. But also, if we don't address a question, or if you have a question that you think about after the fact, please reach out to any of us here at ESRI. On this screen, you will see the contact information for myself, Mike King, but also for our presenters, John and Phil. So please, if you have questions, you don't have to do it right now, but please let us know how we can support you. So one of the most common questions we get is, will this webinar being viewable after today? And the answer is yes. We're recording the webinar, and we will be posting this on the ESRI industry page, and we'll also be sending a link to everybody who's attending here. In addition, I want to let you know that there has been a lot of good information and content provided here, and there's some links here that you're seeing here about the 3D base map solution that Phil talked about, but also there's some other information about learning about 3D. These links are here. You can write it down if you want to, screenshot this screen if you want to, but we will also be providing this afterward, this webinar. So if you don't capture right now, that's quite all right. You'll get links for this information. So a couple questions that I wanted to throw out to Phil and John is, maybe we'll start with Phil, is that can you comment as to like what 3D data is available from ESRI for an agency today?
Sure. So the first, as I mentioned, is building your city from the ground up. We do make an elevation layer available worldwide. That is something when you open Scene Viewer from the top of Enterprise or ArcGIS Online's home screen, you'll just see map and scene along the top. You'll find that our elevation layer has been automatically added. You can create your own custom elevation layers from that LiDAR, as I'd mentioned before. But other data is really mostly been developed by our users, so that most major cities are actually available in 3D. I mentioned that they've made this kind of investment, and they're working on sharing this both inside but also publicly, so that in Scene Viewer you can search for buildings in San Francisco, Chicago, San Diego, New York, and find that there are already 3D models that are accessible. We are looking into licensing some other data that can be useful for 3D base map. We're not there yet. So the recommendation ultimately is that authoritative data really starts at home, and so recommend using that 3D base map solution to create some of your own data from LiDAR.
Perfect, great. You know, Phil, I'm going to stay with you here. Maybe you can address this question. Do you foresee any 3D base maps being used to speed up humanitarian work before or after a disaster?
Absolutely. In fact, we've already seen it. I know that FEMA currently has a program that they're using 3D mapping. They're developing integrated mesh to do some initial damage assessments for larger disasters. So that ultimately gives a view of the damage immediately. Now that's created by integrated, or the data type is integrated mesh. John was showing an example earlier of integrated mesh that was captured with drone to map. And you can understand how valuable and useful that can be, either before an event or as a part of pre-planning, to be able to capture a realistic 3D picture of the as-is environment. And so, yep, both disaster and humanitarian efforts. Visualizing thematically has been the other. So, you know, a lot of with the COVID-19, we've seen some thematic visualizations of the number of cases that have also been really interesting. And I think 3D really helps to tell that story.
Great, thanks, Phil. How about I switch to John for a couple questions here? And John, this is kind of a two-part question. So at first it would be, what is NENA doing about standards for 3D mapping? And then if I could kind of add another question is, how is the technology fits with the NENA ESRI architecture? And I'm not sure if you could address either of those questions.
Yeah, good question. So the next generation 911, of course, is lots of you may know, is really a modernization of the nation's 911 system. And NENA is a standards body that works very hard to develop standards that define interfaces and functional elements for how the new next generation 911 system is going to work. Well, going back many years ago to the start of it, the design for this new system really included support for 3D. So and one example is how civic addresses or street addresses are represented in next generation 911 for transmission over ESRI nets. So the location object, so-called presence information data format location objects, or PIDF LOs, they can contain civic address street addresses that contain sub-address elements, and the sub-address elements can include information like floor and also room. So it is a defined structure for sub-address elements that can relate to three-dimensional positions inside of a building, such as a floor or a range of floors, things like that. So definitely it's support for 3D is sort of woven into the architecture of next generation 911 and ESRI nets. And real recently, NENA has just fired up a work group for 3D GIS for 911. I'll be on the work group. Phil will be on the work group as well. And I think it's important because a lot of the standards and the FCC rules and the work of the carriers, that's all kind of getting the technology in place to do highly accurate and precise three-dimensional tracking of mobile phones calling 911. But again, the piece that we need in order to make that actionable is really 3D and indoor maps. So 3D and indoor maps have to be built, and that's the big challenge for the industry right now. Geocom as a company is really laser focused right now on bringing public safety location intelligence that includes 3D and indoor mapping for 911. So it's the stage is really set. I mean, the FCC put these rules into place a number of years ago. The NENA standards for NG911 emerged a few years ago. but the technology parts and components are finally lining up. They're getting into place now to a point where we can really begin to leverage these types of technologies to provide real value of reducing emergency response times and ultimately saving more lives and protecting more property during emergencies.
Great, thanks, John. So let me, John, one additional question for you. And Phil, you might have a thought on this as well, but let's start with you, John. And Phil, if you have something, great. If not, that's okay. But what tactical mapping capabilities does ESRI enable for indoor mapping?
Yeah, I'll take a whack at that, and then Phil can take over. So Geocom tactical mapping applications are built around ESRI technologies. So we use the latest and greatest ArcGIS runtime, and then we also use ArcGIS Enterprise, ArcGIS Online, and we make extensive use of the ArcGIS JS API. And so that gives us great capabilities for providing to our end users floor-aware displays. So displays that show outdoor maps, but also indoor maps with tools like floor pickers. So call takers and dispatchers and emergency responders can easily toggle back and forth between different floors. And then the great 3D capabilities in the ArcGIS JS API just give us a fantastic capability for presenting all of this in 3 dimensions. We can display, a 3-dimensional location of a caller, with an elevation. We can use tools like the line of sight tool tactically to enable our users to, envision what the bad guy can see from their position versus, what's visible from where they are. And so it's a great tactical planning and operations tool in that scenario as well. But I'll let Phil take a stab at the question too.
Yeah, that's a great answer, John. Yeah, there's the couple of those use cases that we keep coming back to when it comes down to tactical operations and indoors is understanding the placement of cameras. And John had a great example there with the stadium example, where you could have hundreds of cameras that are set up, but making sense spatially of the views that you're looking at is really a 3D problem. So being able to maintain that data, maintain those views, immediately go to the camera that's necessary to help you to give that picture of, well, where that is, and helping either dispatchers or first responders make sense of spatially of where an incident is or where crowds are collecting. That's a first one, and as John mentioned, line of sight tooling, the ability to create view sheds. And there's another one of those, solution that's available called a visibility assessment solution. And that enables you to create really this kind of quantitative view shed. Typically view sheds are from a single point to what that can see, but now space to space. So looking at an entire building that's able to see into a high profile area or an area of concern, how complete is the view from each of those windows? That's something that can be answered in order to be able to help to prioritize risk and risk management.
Awesome, great answers, guys. Thank you. So I think we have time for probably one question. We have other questions, and I just want to ensure that anybody on the call, that if we haven't addressed your comments, your questions, we will definitely follow up with you after the webinar. But this last question, which I've heard not only in this webinar itself from this individual, but also in other times around, is there a plan to provide a 3D mapping as a service at a national level? And I don't know if that's something, maybe I'll ask you, Phil, if you have any thoughts or comments on that happening or any plans on that.
Sure. Well, it's definitely something that we get asked, and it's not without its challenges. I liken it to where the responsibility lies for the authority of data at some points. So that what I think will be most immediately achievable is that LOD1 view of buildings within across the national infrastructure that's very simplistic, helps to give that perspective of where buildings are, but at the same time, it doesn't have the level of detail that may be necessary in understanding where the floors are, what's inside those buildings. This is something where I think Europe is sometimes a bit ahead of us on. They've prioritized the collection of 3D data based off of public safety and security concerns. And so it's a legal requirement to actually maintain like the BIM data, that Revit data that I was showing before, in a central repository, so it can be made accessible for first responders very easily. So I think we've got a bit of learning to do. I think also from ESRI's perspective, we do have some licensing to investigate to ensure that we're able to at least provide a very generalized level of detail for our users. Again, it is a very challenging process to be able to bring together all of the building data for the entire U.S. But you know, I would suggest that there's a responsibility that's really required from each agency jurisdiction at this point to build the highest level of detail that they're able to.
Great. Well, thank you, Phil. Well, I want to just, as we kind of close out this webinar, I want to give a big thank to you, Phil and John, for your support today. It's great jobs, and we really thank you for supporting this. We thank everybody who attended today's webinar. Again, this will be, it has been recorded and will be posted for view after this event. And on behalf of, from everyone at ESRI, in this COVID world that we live, please continue to stay healthy and stay safe. Thank you and have a great day.